All right, so we're going to try to find the constant difference for this hyperbola with foci at 0, 11 and 0, negative 11, and P is going to be on the hyperbola at 0, 7. So there's a generic formula to find this constant difference, and here it is. It's basically the absolute value of these two distances, or these two lengths, subtracted from one another. Now you can always plug and chug these and go through the calculation, but I'm gonna actually go through like the concept of this, because actually there will be times where this will be actually more work for you to take like a minute to just step back and think about where these points are in reference to one another. Then it's actually gonna be faster to find this value. So let's just plot these 3 points. So F1 will be at 0, 11. We'll draw like a little sketch. We'll say 0, 11. F1 is over here. And F2 is at 0, negative 11. So it's gonna be like directly below. Just draw it like over here. And then point P is at 0, 7. So maybe like over here or something. Not drawing the scale, but just to get a sense of what's going on. So what this is basically calculating is the difference in these two lengths. So we have one length from P to F1. So we have P, F1. And then we have another length from P to F2. So we find those two lengths and subtract them from one another, and that'll be your constant difference. It doesn't matter which one you subtract from the other one, because you're taking the absolute value. So if you get a negative number, you just change it to be positive. You take the bigger minus the smaller, you'll get the positive still. So it actually doesn't matter. But if we were to put this formally in this way, like what these x1, x2, y1, y2, y3, and x3 all represent are just the coordinates of these points. So we like to put the point on the hyperbola at x3, y3. That's usually the formal notation. And then we can put like, say that F1, that's at x1, y1, and then F2 is at x2, y2. So you basically just take those numbers for each of those variables, plug it in here, and calculate them. So what this is actually giving, so this is giving the length from F1 to P. So it's actually doing this, it's actually the first part of this formula. So if we were to write this like out, it would be like the difference is equal to PF1 minus, and then this part would be that PF2. So that gives you that length. Now the thing about this problem, these points are just on top of one another. So you can just find how long these lengths are by just counting them. So if you count from P to F1, we just go from 7 to 11, that's just 4. And then from P to F2, from 7 to negative 18, from 7 to negative 11, that's just going to be 18. So we could just do 18 minus 4 or 4 minus 18. Their difference is just 14. So that's just your answer. If you do the calculation, you would get that same value. All right, so let's now look at problem 3. So we're going to find the equation for this hyperbola with the covertex at negative 16, 0 and a foci at negative 20. So the first thing that we want to recognize is that since the covertex is at an x value, that means the vertices, or the vertex, will be at a y on the vertical axis. So this is going to be a vertical hyperbola. First thing, always figure out whether it's going to be vertical or horizontal hyperbola. Now, since it's a vertical hyperbola, that means you're going to have an equation in this form, y. Oh yeah, no, y squared. What's going on with my squares? Y squared over a squared minus x squared over b squared equals 0, or equals 1. You don't have to worry about h and k because this is told that's centered at the origin. So we just need to figure out what a and b are. So a, b, and c will sometimes, you will need to figure that out. So to covertex, we'd like to represent with the b. So then b will be 16. The foci are c units away from the center. So c is 20. So now we just have to figure out a. And for that, we can use the equation c squared equals b squared plus a squared. C is 20, so c squared will be 400. B is 16, so b squared will be 256. Plus a squared, take away 256. And a squared is 144, or then a is then 12. So now you can just plug these values into here. You get the y squared over 144. I should write a squared over 144 minus x squared over 16 squared over 256 equals 1. And that'll be your equation. So look at number 4. Number 4, we have the vertex at 24, 0. So this tells us that it's going to be a horizontal hyperbola because the vertex or the vertices are going to be on the horizontal axis. So then our equation for a horizontal hyperbola, we're going to have x squared over a squared minus y squared over b squared is equal to 1. We gotta find the a, b, and c. Sometimes we don't need c, but always, just in case. The vertex, remember, a units away from the center, and this is simple since the center is at 0, 0, so then a is 24. The b will correspond to the covertices. The c at the foci, so c will be 25. And again, we can use the equation c squared equals b squared plus a squared to find what b will be. C squared is 25 squared, which means 625 equals b squared plus 24 squared. Forgot what it was. 576. So 625 minus 576, 49 will be b squared, and then b will be 7. And so then our equation will be x squared over 24 squared, so over 576, minus y squared over b squared over 49 equals 1. There you go.